Hi, folks. So I'll get started, and maybe other people can keep coming in as they come in. I'm going to be talking about building Git-push workflows for Kubernetes. I am Tanmai. I am one of the founders at Hasura, and where we've been kind of building tools to make Kubernetes easier for application developers. And one of the things that we do is provide developers Git-push workflows so that they can kind of use Kubernetes more easily. We started using Kubernetes and Docker back before they were a thing, before 1.0. We've done all the wrong things that you could with Docker and perhaps with Kubernetes too. We used to have multiple processes in a single container. I don't know if anybody remembers Fusion base image, which would have like SSH running in it as well. We also started using, the way we construct our entire platform is basically an operator. And this was before the term operator was there. So we used to have config maps, and then we would listen to changes on the config map. And that's kind of how our operators would work, which is now custom resources. I come from I'm a developer. I'm not a sysadmin person or an ops person. And the first time that we started using Kubernetes, and the first time I looked at Kubernetes and played with it, it was supremely amazing to me as a developer because I kind of felt like, hey, I have these ops things that I want to do, and I kind of spec them out. And the Kubernetes control plane is like my buddy that lives inside the server or lives on the cluster, and then I just tell it to do things, and it just does things for me, right? And that was very empowering as a developer. And I think this year especially, we're going to see lots of tools that come out that kind of make that narrative happen for the developer, where I just as a single developer can build something fairly complicated fairly easily, right? One of the things that changed the life of developers when they started approaching ops concepts was the Git-push workflow, right? So you write code, and with Heroku, you would do git-push, Heroku master, and it would just go live. And this was just mind-blowing, right? This was super mind-blowing because I only work with Git, and I'm only using Git, and this is my source code, and I do a git push, and the source gets deployed, right? There's no unnecessary abstractions for me as a developer, right? Because Heroku has to do certain ops things, so their backend does ops things, and it just happens. And now we're kind of reaching the same place with kubectl and Git, where everything that you want to do can be built using just these two systems, right? And the idea is that if you can use these two tools well, then you can build your own Git-push workflows. And if you're building, and the main idea behind building these Git-push workflows that does like a Git-push cluster master or Git-push to your GitHub or Bitbucket or wherever, is that you can kind of simplify DevOps and pipelines for the developer. The developer doesn't have to think about DevOps or pipelines, right? I just think about Git-push and my work gets done. So let's kind of dive in with a supremely simple example, which is the most basic thing that you want to do, the most basic DevOps task that a dev would want to do, which is build and deploy. So I have source code on my machine, I can test it locally, and then wherever my source code at the current commit is, I just want this to be deployed. This is a fairly straightforward thing to do. I would do a Docker build, tag it with my registry name, my image, my tag. I would push it to the registry, wait for the push to happen because, hey, and then finally when the push is done, I would use kubectl, and I would patch the deployment or whatever daemon set that I was using with this new image, right? This goes away into just one command, which is git-push dev master, right? And this is the kind of tool that we want to build, or these are the workflows that we want to set up. That's kind of what I'm going to cover in the next few minutes. So if you're building this, the first thing that you need to understand is, hey, what are Git-hooks and why are Git-hooks relevant? So when you run any Git command, Git offers you the ability to kind of add scripts or hooks to any particular command that will run before or after whatever Git does in that command. And that kind of allows you to tweak behavior or add extra behavior. And so when you do Git push, there are three specific hooks that are of interest. The first is a hook that runs on the client side. So there's me, which has my machine, who has my machine, and then I have a Git installed on my machine, and that is the client. So whenever I do a Git push, there is a client-side hook that is executed called the pre-push hook. The pre-push hook, if it succeeds, will allow the push to continue. If it fails, will ask the push to get aborted. Similarly, there's a server-side hook. And the idea with the server-side hook is that you have a pre-receive, which executes before the objects are taken and put inside the Git repo. So that's the pre-receive. And then once the objects are taken and put onto the Git repo or put onto the file system, the post-receive hook executes. And the post-receive hook, even if it doesn't work, cannot abort the push process that started. Hooks are super simple to use. You probably already have hooks in your repo if you've not tried it out. If you just go to .git, if you go to any Git repo, go to .git/hooks, you'll find a bunch of sample hooks. Just remove the .sample from the name, and those hooks will start working for you. You might have to chmod x them, or maybe not. And so if you want to build the system, the most obvious architecture, I should have done animations on these, but the most obvious architecture that would emerge is, hey, you need to have a Git remote agent on the server that you can actually push to, right? And then that is the agent that is actually going to do the Docker build and then do the kubectl apply image, those 2 commands that we wanted to run, 3 commands that we wanted to run. And then this Git remote agent will obviously need some configuration. So the configuration it would need is the sh key so that you can push to it. It would need the Docker file path so that it knows where the Docker file is so that it can build it in your repo. And then once you have a configuration file, you obviously need something that will apply the configuration files to the agent, right? And if you're not consuming something as a config map, then the only other way, or the best way to do it is to use a custom resource and to use an operator or a controller that kind of syncs those changes with the Git remote agent, right? So that's kind of what the architecture looks like at a high level. You have your computer, you do a git push, it goes to the Git remote does a Docker build, and then patches the deployment, right? So the setup that I would need to do as a developer in this kind of a workflow is I would create a custom resource called a remote. And in that remote, I would specify that this is the Docker file, this is the deployment that you should patch, this is the Docker file that you should use from my Git repo, and these are the authorized keys of people that are allowed to push. Excuse me. And so I'm going to do a quick demo. I shall pray to the demo gods, old and new. We are in the home of Loki. So I have a super simple nginx deployment setup. Oh, wow. I don't know. And so let me just open this on Chrome. All right, so this is just an nginx file, just says this is some old content. And this is backed by a deployment. Right? And what I want to do is when I do a git push, I want all of those things to happen, right? So fairly straightforward. If I go inside my HTML directory to index.html, I'm just going to take this off and make a change, and that's git commit -a changes. This is the worst commit message. Don't do this directly on master, but and then I'm just going to deploy this with the git push dev master, right? And then I'll kind of show you how that got set up in the first place. So that's the Docker build that's happening. It's nginx, so it's super fast because it's just copying files over. And then it does a Kubernetes rollout, right? And now if I refresh this, that's me with, yeah. Right? And that's kind of it. That's kind of it as a developer. Because you have Git, you can do simple things. I can do simple things like, I don't like this deployment that I just made. And so what I'm going to do is, hopefully this is the right commit. I'm just going to, again, don't ever do this. I'm just going to do this for a demo. And so the idea is that, hey, I have my code is committed, I'm just going to do a git push and it should work, right? There is nothing more or less that I want to think about. And the way this works is that I have remotes that are set up here. And this is the dev remote. I'm going to come to the other remotes later, right? And I'm pushing to this remote. So that's the IP of my cluster. That's where the git remote agent is sitting. If I'm going to try to show you the hooks as well. So that's the custom resource of the remote. That's the custom resource that I set. So you do a kubectl create -f remote, and you create this remote. I can even do a get remotes to show you that this was the custom resource that captures that remote. And then this kind of remote gets applied. And whenever I do a get remote dev -o YAML, the operator that is sitting there that is syncing these changes with the git remote agent, with the git remote agent, that kind of publishes the remote URL. So that's the remote that I add to my git repo. So I do a git remote add dev as this, and then I can do a git push dev master. Fairly straightforward, right? The nice thing about this simple setup is that it's powered by just a pre-receive hook. The pre-receive hook is doing all the work. I was thinking about copy-pasting code onto my slide, then I realized there's a billion-dollar industry in showing you code on the web. That's what I'm going to try to do. And that's essentially the pre-receive code that is powering this, which is basically just taking the deployment name, and then doing a Docker build, and then doing a kubectl apply, right? That's all of the work that's required to make this work. What we did was we kind of took this and we put this into a small package called GitCube, which is a package that you can run, which comes with a controller, a remote definition. You can customize the controller. You can customize the Git remote agent as well. And you can just take this and then run this on any Kubernetes cluster. The good thing about running on a Kubernetes cluster is that you can RBAC it to do only the things that you want it to do. And you can access Kubernetes resources as well. That's the next demo that I'm going to try to show you. So the benefit for the developer is fairly obvious. I just need to use Git. The benefit for the ops people, or if the developer is doing an ops task, is that I can kind of use my hooks to use Kubernetes resources directly, right? And one of the resources that become useful when you're writing these small ops tasks is access to secrets that are stored locally on the Kubernetes cluster. So for example, let's say I want to do a really simple thing where whenever I do a git push, I want a Slack notification to come in, right? And the Slack notification needs a secret so that it can actually make that, the API call to Slack, right? And so if I do a k get secrets or a kubectl get secrets, not secrets, you'll see that I have a Slack secret, right? And that's essentially the secret that I want my hook to use, and then make an API call to Slack saying that something has happened, right? And again, all that you kind of need to do for this is, I'm going to load up our Slack and hope that nobody says anything embarrassing. And then all I need to do is write a hook, and so that's what a post receive hook would look like. Let me zoom out a little bit. So if you look at the hook is basically using kubectl to get access to those secrets, and then just making a curl call with Slack, right? And this is just a simple idea. This is not what you would probably do. But this idea is kind of to show you that you have direct access to kubectl and to Kubernetes resources inside the Kubernetes cluster, which just makes a bunch of small things much easier to do. And so I'm going to do a git push dev. Let me just make that change again. And so this is going to run not just the Docker build and the Kubernetes patch, but it's also going to run the post-receive hook. And the post-receive hook is what is executing right now, which should give me a Slack notification saying that, hey, deployed this particular commit on master, right? So that's kind of how you could kind of customize this to add whatever hooks you would want to add to that later. If you take a step back, this is kind of interesting because what if we could extend the same idea to do more DevOps stuff, right? And I'm sure you guys are already, or you all are fairly aware of the different kinds of things that you can do when things are declarative. But as a developer, you would want to build and run unit tests. You want to deploy code, which is kind of what we did. You'd want to deploy configuration for your entire microservices kind of application. You might want to run stateful migrations. This is the painful bit. Because these are like database migrations that you need to run when you do a git push. And you need to run integration tests as well, which are kind of tests that are spanning multiple microservices and checking if the dependencies between microservices work well. And what we would ideally like to do is move to a place in the future where The only thing I would ever want to do as a developer is do a git push, and all of these things should happen. Which means that if I want to undo them, I should just be able to check out to a particular commit. And again, all of these things should just work if I deploy that again to my cluster. So if I switch to a different branch and I do git push dev my branch to the cluster's master, those deployments should just work. And I should not have to think of anything else as a developer. The way this can work and the way this will happen in the next few months or in the next few years with Kubernetes is because of the way Kubernetes works. And the most awesome thing about Kubernetes is essentially, for me at least, is that you have these YAML files, and then you have control loops which apply these YAML files and make complicated things happen. Like they create containers, or modify IP tables rules, or do resource allocation, or mount volumes onto VMs, right? And this was the idea behind Kubernetes. And when we were hacking around with this, we used to use config maps, and we had our own listening agent thing that CoreOS decided to call operator. And then this pattern essentially now allows you to extend that idea to do whatever you want. Where you have YAML files, you have your own operator. This operator can actually do the stateful, procedural, hard things. And then it can kind of do whatever your application needs to do. So for example, if you're running migrations, your operator is going to take those files, read the state of the database, and then figure out what migrations to apply. Or if you need to initialize state, then you can run a bunch of pods, wait for them to finish, and when those pods finish, you make change on the volume, or unmount the volume, or mount the volume. And again, those things should just happen from the point of view of a developer that is just literally modifying those YAML files, right? The important thing to understand when we're doing these small ops things, right, is that there's no notion of sequence, right? All of these tasks that we are doing on git push kind of happen asynchronously. So for example, whether it is a custom resource YAML file that I created, or whether it's a Docker build that I started doing, or whether it's a kubectl, or whether it's a deployment that I patched with kubectl, those things kind of just happen in any order, and eventually the right things will happen, right? And so if you take these particular common tasks that you have, which is build and test, deploy, including stateful deployments and integration tests, what would the declarative versions of those look like? Declarative in a way that you could just run them randomly, and eventually it would everything would just work. So building and running unit tests is pretty straightforward. You'd use a Docker file. You don't need anything else. It is completely declarative, contains your entire set of dependencies that you need to capture for that particular microservice. If you want to do a production build, you again don't need to do anything. You just use a multi-stage Docker file. You're pretty much done. You don't need any external tooling. If you want to deploy configuration, let's say you're changing an API gateway or changing ports, that's just updating Kubernetes manifests. That's also pretty straightforward. If you're doing stateful tasks, and what is going to happen is that every single stateful microservice or agent that you're going to deploy in Kubernetes is going to start coming with its own operator. And that's already a trend that we're seeing. And we're going to have lots of little operators for each kind of database or something that is stateful. And then this operator will have a custom resource definition. And if you update an instance of that, or you update the custom resource, that particular operator will take care of applying the stateful task for you, right? So custom resources or custom resource definitions become the only way to kind of operationalize these stateful tasks. And they should also just execute without depending on any external notion of a sequence. For integration tests, you would have jobs, and you could just have an init container that checks if the dependent microservices are ready, and then kind of run whatever test you need to run. So for example, so what this would mean is that maybe we're kind of reaching a place where you don't need to have pipelines anymore. You just have things that are declared, and you don't have this notion of saying that I have CI/CD/pipeline. I mean, you still do, but you kind of also don't, because everything is just spec'd out in these different declarative files, and then they're just given off to run. And if you look at a GitPush workflow, then as soon as you do a git push, you just want these manifests or these configurations to be applied, and everything else will just run. And so what I'm going to do is show you a small demo of what something more complicated would look like. This is not something that's a part of GitCube yet. It's something that is a part of the Hasura platform operator that we have. But this is just kind of a cute demo to show you what is possible if things are declarative, things are written as custom resources, and you have an operator taking care of rolling out that change for you. Let me head to... So I have I have again an nginx deployment setup in a particular Git repo configuration that is required for this new kind of Git push to work, where it also picks up other configuration files and not just a Docker file. I have something deployed on this subdomain www, which is just running a simple nginx pod. And now what I'm going to do is I'm going to change the subdomain, right? And as a developer, I have a routes.yaml, which is a custom resource. I have the subdomain here. I'm going to change that subdomain to app. And then I'm going to write another hideous commit message. And this is kind of all it should take for running, for making that change happen, right? And you can imagine that on the back of this, what happens is actually fairly straightforward. All you're doing is you're updating a custom resource, and your operator is going and restarting the deployment of the API gateway and saying, hey, this is the new subdomain or new route configuration that you need to have, right? And so if I head to this, you'll see that it's down. And if I go to app, you'll see that this now lives at app, right? So this is a super simple demo of again saying that how life can again become one level easier for the developer by just having this kind of tiny automation that you build in. A slightly harder example is database migrations, and so I'm going to show you that. So there's a migrations folder that I have, and this is built to work with Postgres Migrations, or this is kind of like a lightweight migration framework on top of Postgres. And so, as you can see, right now my migrations directory is empty. I don't have anything in it. I'm just going to open up PSQL so that we can see the changes as they happen. So I don't have any tables in here. I just have a table called Schema Migrations. It's kind of like a Rails-like migration framework, right? So you have a Schema Migrations table, and I don't have any tables in it. What I'm going to do is I'm going to declaratively copy those. I'm going to copy those kind of declarative migrations. CP. I'm going to show you what those migrations are. So it's a bunch of different tables. It even contains some sample data, which is just like an SQL file. I'm going to open up a few of them so that these are just typical database migrations that any application would have. So that's a create table. I have some sample data here as well, just to show you that. And so that's some sample data, or just a copy statement or a bunch of insert statements. And now all I need to do is git add and git. And the same idea of picking up these custom resources and having an operator that actually takes these changes and applies them on a database, essentially running those kinds of Rails migrate commands. This is not Rails, but just to give you an example, is something that you can fairly easily do. Because now if I do a /d here, you'll see that those migrations have gotten applied, right? And when you're writing these hooks, it's also really easy to write these hooks because whatever kind of database secrets or credentials you need are already there on the Kubernetes cluster. There is pretty much nothing. What the hook that you're writing is essentially the same bash script that you would have written if you were trying to automate your workflow wherever you were. And if you had direct access to the database as well. So select star from author. Shows you that these kind of data has been imported as well. So that's kind of what Git push can let you do, right? And it's so easy. And you can just kind of do this for yourself or whatever tooling you need to have, whatever application or whatever framework or whatever database you have. And you kind of don't need to have any more abstractions on top of this, right? kubectl, Git, writing your own scripts is just more than enough for these kind of simple use cases. There are a few things that are not easy to do with this idea of making everything declarative, even if it's possible to run stateful things with operators. One of them is secrets, which is that you cannot commit them to Git, obviously. And so you need to apply or manage secrets external to this workflow. So that's something that's never going to become a part of this GitOps kind of movement that's happening. The other thing that's also a little cumbersome is templating, which is that if you're templating Kubernetes objects, they're not actually Kubernetes objects anymore, right? So this is one of the painful things about templating tools today, which is that if you have a deployment.yaml, the deployment.yaml is not actually a kind deployment, right? It's actually templated with these random things. And so we don't know what a Kubernetes native kind of templating would look like, where the templating would kind of happen on the server side, but the only tool that you need is kubectl or kubectl. That would be nice. But till then, you have Helm. And then what you can do with Helm is, again, when you have your hook, your Git hook will basically run a Helm command instead of doing a kubectl apply or a kubectl patch, right? So again, the values that you're templating, the values.yaml file, these will again not be a part of your Git repo. Because you might want to have these configurations that are stored outside the Git repo. So that becomes another piece that doesn't get handled very neatly with the GitOps kind of idea. There is another problem, which is fairly common here, and that is the idea of like, how do you say that I need to scale this deployment up or down? Or this needs to kind of auto-scale, right? Where does that configuration go? Does that go in the deployment.yaml? Is that also declarative? And there is a school of thought which says, yes, let's make that declarative too. So if you want to scale things up or down to a fixed value, then you use Git-based tooling to make that happen. But the other thing that's also happening is that when you say things are auto-scaling, the fact that a deployment is auto-scaling is also declarative. And so that handles at least some kind of min-max use case by being declarative, right? So you don't need to keep changing your Git repo to make that happen. There's conversation around releases and doing canary or blue-green deployments, which is also something that is traditionally just a completely ops task, not something that developer has to worry about. And then you should go look at the GitOps talk with Istio, where Istio also runs with this idea of having a controller and having manifests, and you can kind of change those policies declaratively, and the operator will make it happen for you, saying that, hey, 90% traffic here, 10% traffic here, which gives you your canary or blue-green deployment. So that kind of covers a set of things that I want to talk about with GitOps. You guys, you all should check out the GitCube repo, which will just help you run these hooks for yourself on your own Kubernetes cluster. You can run it within a namespace as well. Should not be a problem. I'm going to move this to presentation mode. What's on the roadmap for GitCube is that you don't want to write bash all the time. So we're adding features to GitCube to make it easy to write these hooks without actually writing the git hook bash portion of it, which is actually reading the particular commit ID or the revision and then figuring out what to do with that particular commit. And then creating these kind of boilerplates or plugins for small hooks or tasks that you would like to execute. Also a UI to see what your past pushes are like. We're trying to hoping that this doesn't turn into a full-fledged CI/CD tool, but does work for certain small use cases. And then we'll also kind of make this case of making the git push that is synchronous become equivalent to an asynchronous vendor webhook. So having a git push to your GitHub and having that asynchronously apply. There's a small caveat with making git push work for the developer is that things should be synchronous, right? So if you look at the deployments that I was making when I was doing git push, this actually waits for the rollout to finish, which is fine for small use cases, which is not good if you're running a large battery of tests or if it's a long-running task. But this is good feedback for the developer, because as I'm doing a git push, I would like to know if something's working or something has failed. Like if migrations did not get applied, I don't want the push to happen at all, because I know that migrations are critical for my application. So making that equivalent is also a bit of a task, which we'll kind of try to make happen. That is all from my side, and we are also hanging out at SUC30. So please do come and talk to us about developer workflows on Kubernetes. We're also doing a lot of interesting work with multi-tenant Kubernetes to kind of do the 0-to-1 scaling, so that if a particular namespace is not active, it gets scaled down and scaled up automatically. So if you have any of those kinds of things to talk to us, you want to talk about them, do drop by our booth. And do check out GitCube and let me know what you guys think. Thank you for having me. I have a few minutes for.